Okay, so I tell you here that a small swimming pool with a 10,000 gallon capacity is being filled at a rate of 5 gallons per minute. Initially, the pool contained 100 gallons of water. So the first thing we're going to do is find a linear function v which models the volume of the pool at any time t. So let's just really quickly review what a linear function can look like. I can write a linear function of the form y equals what? Something times something plus something else. Okay, so y equals mx plus b. So we're going to find a function v of t. And it needs some slope times x plus some y-intercept. So in real life scenarios, the slope of this linear function is equal to what? We said something earlier, a something of change, a what of change? Rate of change. So this slope is equal to the rate of change. What is the rate of change? Oh, before I move forward though, there's a glaring typo here. I have t's and I have x's. I have to pick one. I need to use time t. That should be a t here. That's all. I need to be consistent with my notation. All right, so what is the rate of change in this example? 5 over 1, so I'm just going to write this as 5. Okay, so my rate of change is 5. What's the y-intercept? 100, because we're talking about the volume of the water, so 100. And that's it. You've done it. You found a linear function which models the volume of the pool at any time. Okay, so this is for part A, and I don't know why I squished that in there. So there we go. I'll label these things just to make it really clear what everything is. This is the rate of change. And we got that here. This is our rate of change right here. And then our y-intercept is here. This is our y-intercept. And we tease that out from here. This is the y-intercept. Okay, so now we have to figure out how many hours will it take to completely fill the pool. So my question is, are we trying to find V or are we trying to find T? T, we're trying to find hours, so that's time. Time. Okay, so before we move too far, I want to ask you guys, our rate of change, is it in hours? Minutes. So we're going to have to deal with that at the end. So for now, let's just focus on finding a value for t, and then we'll figure out how to make it into hours. So how can I set this up? What's important to know here? 10,000 gallon capacity. So it is important to know, you're correct. It is important to know that this pool has a capacity of 10,000 gallons. So here's the capacity. So 10,000 gallons, and that's from here, right there. So that's the capacity. So what can I do with this 10,000? Is this 10,000 a value of V or a value of T? You are right. This 10,000 is a value of t. So I'm basically going to rewrite the whole function. We found v of t equals 5t plus 100. Then I'm going to replace the v of t with 10,000. Okay, so now I can go ahead and solve this. So I'm going backwards. I'm trying to get this t by itself, so I'm going to subtract 100 from both sides. This one's easy. 0. What do I get on the left? Can someone tell me what I get on the left? Yep, 9,900. And I should keep things lined up. 9,900 equals 5t. I'm out of space here, so I'm going to move my work up here. Actually, before I do, I want to tell you guys, never just do this. Never write equals and then go t equals and write the answer down, because technically this is not correct. Equal sign literally means that both things on either side are the exact same thing, but t and 5t are not the same in this case. So I'm out of space, so I'm going to move my work here. So I have 9,900 equals 5t. To get t by itself, what's the next thing I should do? I should divide by 5. You guys are correct. Okay, help me out here. Someone get a cell phone out. Please get a cell phone, a calculator out. What is it? 1980, yeah, so 1,000, oops, wrong color, excuse me. 1,980 equals t. So again, remember, this is in minutes. So this is in minutes. How do we figure out how to get to hours? Ben, yeah? Divide it by 60. And now if you guys don't see how we came about that, I'm going to quickly, as an aside, I'm just going to do a full unit conversion here. So I have 1,980 minutes, and I know I want it to be in hours. And actually, this is tight. So let me zoom in, and I'll go back to zooming out, but for now I want to show you this. So I want it to be in hours. Okay? So I need to do a conversion. I need to divide by minutes. And then I need to figure out how many minutes are in an hour. Can someone help me out? How many minutes are in 1 hour? 60. So this is why we divide. So if you don't see it, always write it down as a fraction with conversions, because then look, the minutes cancel out. And now you know to divide 1,980 by 60, and the only thing that's left is hours. So if you don't remember or just honestly forgot how to do conversions, never learned it, hopefully this will help you out. Always try to write down the units you have, write an equal sign. I know I want it to be hours, and I need to cancel out minutes. Okay, so with that said, what comes next? What's here? 33, yeah, 33. Okay, I'm going to zoom out again. So 33 hours. So it will take 33 hours to fill the pool. 33 hours to fill the pool.